Yeah, hello, ladies and gentlemen. I hope you can hear me well and maybe see me now again. Today I'm presenting a webinar about the life cycle assessment of the Fronius Tauro. Maybe the life cycle assessment of the Gen 24 is familiar to you. We conducted this life cycle assessment like around about 1 year before the LCA of the Tauro, and now we also got the results of the LCA of the Fronius Tauro, and I'm very happy to present it to you today. I will now go offline again, and I hope I can have the control. Yeah, perfectly fine. So your Fronius team for today, that's myself, Leonhard Peberg. I'm working in the team product marketing, and on the right-hand side of me, I have Christoph Schierlinger. That's my colleague from trainings and education. He's supporting me in the chat. So please just use the chat function in the panel, in the user panel on the right-hand side, and just type in all the questions you have, and my colleague will answer them directly, and maybe we can have a short Q&A session afterwards if some questions are still open. A short look on the agenda. I will start with the department which conducted this lifecycle assessment, sustainability by design here at Fronius. Then I will explain to you what is a lifecycle assessment, because for many of you, maybe you don't really know what is LCA, what can we do with a lifecycle assessment as installer, as EPC, as wholesalers. Why is a lifecycle assessment important and will be even more important in the near future? And then we go into detail about the lifecycle assessment of the Fronius Tauro. I will show you some pictures about the data collection. I will present you one specific scenario at a glance, and of course the results of this scenario. Yeah, sustainability by design. Of course, there are specific people here at Fronius in our R&D doing these lifecycle assessments, but before I want to give you a short overview of the history of sustainability at Fronius. This is not the colleague conducting the life cycle assessment here at Fronius. This is Günther Fronius, the founder of the company, who founded in 1945 the company Fronius. The first business unit was the business unit Perfect Charging. You can see here in the background the first device for charging old car batteries. So the idea of sustainability was already born in 1945, although the name was not sustainability, but it was like just reusing old things. And yeah, this idea was born in with the foundation of the company Fronius. So sustainability is like really in the DNA of Fronius, and this yeah is keeping up to now. Of course, nowadays we have sustainability is far more important than in the past, and we have now an own, let's say, department in our R&D, which is called sustainability by design. You can see some of the guys working over there, and we do not do LCAs just for a marketing reason or so. We need the knowledge about about the carbon footprint of our products to know where we stand with the product and where we can still improve something. Because if you're not calculating anything or carbon footprint, then you don't know where you can improve something. And as I said, the topic of sustainability and this cradle-to-cradle approach to get the material in the end of life back into the production, this approach will always be taken into account in future product development by this department, sustainability by design. So these guys are basically part of every product development here at Fronius. Yeah, what is now a life cycle assessment? On this slide, you can see here the 3 pillars of sustainability. We at Fronius, we always talk about the 3 Ps: people, planet, profit. Sustainability must basically or must not negatively affect one of those dimensions. Sustainability must always cover all these 3 dimensions. When we talk about people, so let's call it social sustainability, we talk about fair wages and so on, and working conditions all over the world. This is of course very important. So a product or service must not negatively affect the people, the society. The second biggest part is of course the profit. Of course, we have to do a sustainable business in order to sustain here in the solar industry. Otherwise, we could not, for example, if our Tauro would not be profitable or economically sustainable, we couldn't produce it in the next 2 years. So that's also very important. And then we could not be part of an energy revolution. And the last part where we are with this life cycle assessment is the planet. The impact of a product or a service on the planet can be measured with a life cycle assessment. So LCA is just a sustainability assessment of this environmental dimension of the planet. You can measure this in a very concrete way in CO2 equivalent, for example. Yeah, why we need LCAs now, why we're doing it. The first thing is we need evidence-based sustainability. Sustainability is, in the last few years, got a very sensitive topic. Every company was now sustainable or green or eco-friendly or something, but it needs facts and evidence-based numbers for be transparent here. High transparency is extremely important when it comes to sustainability. Only with this you can refute the accusation of greenwashing, because I would say most of the companies using those green labels also do not really have the scientific data behind it. And this is also the authorities in the EU getting an eye on it. So the European Commission did a screening in 2021, a screening of thousands of websites from big companies, looking for greenwashing, looking for those green claims they're using on their websites and so on. And the result was that in 42% of the cases, these claims are exaggerated, false, or misleading, and could be classified as unfair commercial practices under EU rules. So also the authorities are having now an eye on this greenwashing and environmental sustainable communication of companies, which maybe are not that sustainable as they claim to be. Also, the customer requirements are changing. We get a lot of feedback from our customers, especially wholesalers, that they want to offer a system with the best carbon footprint. In this case, for example, they needed information about the environmental performance, such as the usage of recycled materials to get fundings from the EU. So it's also about the monetary effects. They need this data to get fundings, subsidies, and so on. Subsidies, sorry. They want to know how much kilograms CO2 the production of an inverter causes in their country, for example, and so on and so on. So we get a lot of emails every day that customers are requiring this data. Also, the CO2 pricings are rising. Maybe you know, I put the carbon taxes in Europe on this map here. You can see here, this is from 2021, but I would say quite actual one. So for example, in Sweden, there is already a price per ton of CO2 with 116 euro per ton. In Austria, the price is also coming this year, I guess. So there is something happening, but this will be, of course, rising and then getting more and more in times of climate change and so on. And of course, this price per ton of emitted CO2 is directly passed on to the end customer, because the manufacturers, the company, will not pay these prices. So they will make the product more expensive. So environmentally friendly products are becoming cheaper in the end for customers. And of course, LCA are becoming crucial in this case, because you need to know the carbon footprint of the product to pay this tax, of course. Otherwise, you cannot sell it anymore when there is a carbon tax. Requirements and tenders is also very, very important in the PV industry. I put a quote from PV Magazine here. That's a tender in France, a 700 megawatt tender for a PV system, where the tender must have a certain carbon footprint of less than a certain limit of kilogram CO2 per kilowatt. So in this tender, the module manufacturer, the module which was taken in this tender must have a carbon footprint calculation. So PV modules and inverter with a low carbon footprint will be required in future tenders. I have the latest information on this in France is that in every public tender above 100 kilowatt peak, you need a carbon footprint calculation for PV modules for every tender above 100 kilowatt peak. So this is getting legal, of course, a legal requirement in many countries. So you are future-proof with the Fronius Tauro when you have this LCA data here for the tender requirements. Yeah, now this was basically the status quo, the problem, so to say, but now, of course, we go to the solution, to the life cycle assessment of the Tauro. A life cycle of a product is basically this running the same way with every product or every service, so to say. We always starting with the sourcing phase. It's not depending on a product. We're always starting where's the raw material of the cell phone coming, of the laptop coming, of the inverter in this case coming. Then, of course, the transportation routes between the sourcing, the raw materials, and then the production here at Fronius. There also CO2 is embedded into inverter, so the footprint is getting bigger and bigger. Then again, transportation to the usage phase. In this phase, the customer is putting the inverter into the right place, and then it starts to produce green energy. So in this case, over the lifetime of the inverter is basically working off the carbon backpack, the CO2 backpack, originating from the production and the transportation and so on, and the raw materials, and getting carbon neutral one day. That's the so-called CO2 payback time. I will come to this later on. And then, of course, every power electronics will fail someday, will be broke someday. So in the end, there is also an end of life for the Tauro. After 20, 25 years, you basically have to have a waste management scenario for the Tauro as well. Some pictures for the phases. For example, for the Tauro, we source bauxite, iron, copper, for example, all over the world. Of course, this is then proceeded into other steps. Transportation by train, ship, and truck. For example, we avoid the air freight in Europe as far as possible, and over the globe we try to really use just the shipment of products. The production, of course, is also important. We use 100% green electricity in the production. Then, of course, the use phase of the product. So this is the biggest one, the phase where the inverter is at the customer site. And as I said, the end of life. So there's also a huge gap if you just use the inverter and landfill it or recycle the biggest parts. I also come to that later. Now we dig one step deeper into the LCA results of the Tauro. Of course, as I said, the Tauro lifecycle assessment, this is a scientific model. So it's just a calculation from our R&D. This is not a real inverter in the field where we measure like a carbon footprint. This is not possible, of course, because this is depending on extremely a lot of scenarios and variables and a lot of parameters. So for example, in the first one, you have to select the location of usage. Is the Tauro located in Austria? Is it located in Spain or Italy? There is a huge difference in the location of usage. Then, of course, which PV cells do you use? Which PV modules? Are you using conventional modules and a more sustainable alternative, which we both modeled here? Then, of course, which Tauro do you use in the system? Is it in this case, a ECO 100D or a ECO 100P version, so direct or pre-combined version? And which waste recycling scenario do you select? For example, we selected or modeled 5 scenarios here, from landfilling up to recycling with a disassembly of the 6 main parts. That would be the best, of course. And a lot of additional parameters like extended lifetime, repair processes, and so on. Yeah, the data collection, that's very, very important. As I said, the Tauro LCA is a scientific model, and of course, a scientific model is living from data. You need a lot of data. We collected the most of the data we collected was primary data in R&D. We talked to the suppliers of the materials for the Tauro, and we get a lot of primary data of every components, like for example the fans, which you can see here, the power electronics, and so on. Every cable we modeled in this lifecycle assessment. And of course, there's also secondary data from open databases like EcoInvent, because there is also something we cannot model here. So we took the data from secondary database. Here you can see the depth of data collection we did here. This is just the disassembled DC disconnect of the Tauro. You know, the Tauro has 3 DC isolators, and this is just the parts from the DC disconnector. So we really disassembled everything and measured then the weight and so on. So we did a detailed data collection from 96 components all over the Tauro. This is a lot, I would say. We treated the semiconductor and gold components in concentrated sulfuric acid for the weight determination. This is also very important because the data from the open databases regarding semiconductors and gold was, in our opinion, not good enough. So we did it on our own and treated these materials in acid for the weight determination. And then in the next steps, we adapted, or the official database ECO-Invent, this is a huge global database for sustainability data, was adapted on the basis of the Fronius investigations from the semiconductors. So this is also a huge step where we can really be proud of, I would say. Yeah, on this slide, of course, you can see some impressions from the data collection and production and assembly in Satlet. Here you can see a robot welding the Tauro. Of course, here you have to measure the power consumption of the welding and the robot machine and so on. So everything was also measured in the production and assembly. And here you can see a picture of the end of life of a Tauro. Of course, we do not have that much experience with end of life of the Tauro because we launched it 2 years before. So of course, these products are not in the waste treatment yet. And so we discussed this scenario with the Austrian recycling manufacturer, the Austrian recycling company. It's called Müller-Gutenbrunn. How much kilogram CO2 would be produced with the different recycling scenarios or waste treatment scenarios we selected here in the life cycle assessment. Yeah, and as I said, there are a huge variety of results and scenarios. So all over, this is more than 8,000 different scenarios or results. And so I will present you one specific scenario at a glance to have a very practical related one. And our scenario is a Tauro ECO direct version with 20 years of operation in Germany. We're using conventional modules because the recycled modules are becoming more important in the future. And we used metal recycling with downstream thermal waste treatment, meaning the inverter gets basically shredded in a big shredder. The metals are recycled then. For example, aluminium is taken into the manufacturer, which is producing new aluminium out of it, and the rest of the Tauro is then thermally treated. So thermal waste incineration is done then. On this slide, you can see the climate impact over the life cycle of a Fronius Tauro. In this specific case in Germany, over 20 years of lifetime, 20 years of operation of this Tauro. The most important thing is the climate impact here with 3,800 kilogram of CO2 equivalent. As I said, this is just the climate impact and not the climate benefit. So the climate use of this product is not calculated in this calculation, in this number. I will tell you more on this later. So this is just the carbon footprint of the product, but not the carbon or the environmental benefit the inverter is producing over this whole lifetime of 20 years. This is just a footprint. And this footprint can be allocated into different, let's call it measures or parameters. As I said, let's start bottom up with the waste recycling. We have a negative value here. This I will tell you later why this value is negative. Maybe you know it already because we recycle something here. And when you recycle and reuse materials, then you have a negative balance here, a negative value. That's, so to say, a climate voucher. So to say, let's call it a climate voucher. Then, of course, the components. A huge part of the footprint is coming from the components, 29.2%. Transportation to Fronius and transportation to customer is a very low number. I will explain you also on the next few slides. Also, the production at Fronius is very low number, low impact on the carbon footprint. The biggest number or impact on the carbon footprint is the electrical losses of the inverter with more than 50%. This I will also explain on the next few slides in detail. The night consumption of the inverter is calculated with 17.4%, also a huge part. And of course, the repair of the product is also calculated here in the inverter. The first slide, components by weight. So as you can see here in this chart, these are all the components of a Fronius Tauro in terms of weight. So the heaviest part, as you can see here, is aluminium with 35%. Then the coil, cores, steel. The cardboard is a huge factor here with 9%, 9% packaging here, copper, technical plastics, and so on. So we have, as I said, 16 components modeled here with more than 5,000 pieces, and round about 30% of the carbon footprint is coming from the components. Maybe we take a look at this at the capacitors here. The capacitors have 3.2% in terms of weight, and on the next slide we can see the climate impact now of the components. There we have a different picture here. That's the carbon footprint of the components. The funny thing is aluminium is basically the same, so weight and carbon footprint is 35%. That's just a funny random fact. But the other things are quite different. Let's take a look at the capacitors. The capacitors in terms of weight, let's switch back to the previous slide. The capacitors are 3.2% in terms of weight. And on this slide, we can see the climate impact of the capacitors is 14.5%. So also very small pieces from the inverter or lightweight pieces can have a huge impact on the climate. Also the IGBT modules. The IGBT modules in the previous slide, we cannot even see them because it's under other material groups. But on this slide, we can see the IGBT modules have a huge climate impact with 7%. So that's very, very important to know that also very small components can have a huge carbon footprint. Also, the aluminium is very, very important. As you know, the aluminium, as I said, is one of the biggest thing when it comes to carbon footprint of the component. It has the biggest share here. But in our Tauro, for example, we're using 52% of recycled aluminium in the inverter. You can see here in terms of carbon footprint, the gray part of the chart is all the other components, and the green one is just the alu components. So a lot, or I would say, 35% of the inverter, of the footprint of the inverter is just of the component, sorry, is just aluminium. And when we would use 100% new primary aluminium, then the footprint would of course be even higher. So 1,200 kilogram of CO2 equivalent. The current situation is 52%, and 100% recycling share would be of course our goal. But this is, to be honest, it's not possible because in power electronics and so on, we will not use recycled aluminium because we have to fulfill the conductivity and so on. So a big lever, of course, is the alu recycling share in the product, which is already very good at the Fronius Tauro. Next step is the transport to Fronius. In this case, the transport of all the raw materials and the products, the components to Fronius at Satlet. This is just 1.4% because we try to really avoid air freight as far as possible. We just use it within Europe when we need to, and all over the globe we're using shipment most of the time, and train or rail transportation. So 1.4%, that's quite nothing. Also the production of the Fronius, just 1.2%, that's also very low number because we're using 100% of green electricity to produce our inverters. But this is not the only thing what was measured there. There was measured also the nitrogen gassing, solder paste, compressed air, the cardboard packaging of all the delivered components. So we really got into very much detail here. Transportation to customers, same. I mean, from Satlet from Austria to Germany, in this case, this is of course not that much, but also when we would calculate our Australian example here, this would be not very more than 1% or so. The biggest part are the electrical losses during the usage phase. Why is the carbon footprint so big regarding these electrical losses? You always have to calculate the whole system because the inverter is getting basically the energy from the DC side and invert it to AC energy, to alternating current. And the delivered energy of the PV modules from the DC side also has a CO2 backpack already due to this costly or intensive production of the PV modules. The PV modules are, they produce far more CO2 in the production than the inverter, and this is transported via the energy the inverter is getting from the modules. And this is partly unused or remains partly unused in the inverter as waste heat because of the efficiency. So the inverter has a certain efficiency. In this case, the Tauro has 97.5% efficiency. So we basically lose 2.5% of the DC energy coming from the PV modules when it's got converted to AC. And this lost 2.5% results in 52.8% of the carbon footprint of the whole device, because the PV modules has such a huge carbon backpack, a CO2 backpack, and this is basically not used then, or not all of it is used, and this results in this huge number. When we, for example, would use our sustainable modules here, which we already modeled in the LCA, we could reduce the total footprint of the Tauro by 18%. So the goal here is really to increase the efficiency of inverters, which is basically not possible because it's already very good, and to decrease the carbon footprint of PV modules. That's the way to go. The night consumption is also very important. We also, of course, calculate the night consumption. The inverter also consumes energy at night, for example, for the data management and so on. And this energy must be, of course, drawn from the power grid and not coming from the sun, and thus has an impact, of course, on the CO2 footprint, depending, of course, on the country-specific power mix, because the energy in Australia has a different CO2 footprint than the grid mix in Austria, for example. When just a short excursion example, when we, for example, would use the night consumption with green electricity. Now we calculated conventional electricity, so the grid mix from the country. When we would use green electricity for the night consumption, we could decrease the carbon footprint to 1.4%. So this around about 16%, 629 kilogram of CO2, which would be saved when the customer is using green electricity tariff for the night consumption. And last but not least, of course, repair of the inverter. With the Tauro lifecycle assessment, we also assumed a repair of the inverter. So we assumed that 17.5% of the inverters are repaired, and this would then result in 0.4% of the climate impact. For example, when we have a Tauro now and we exchange a power stage of the inverter, of course we have to produce a new power stack, send it to the customer site. The customer has to exchange it and so on. Of course, this also generates a carbon footprint, and when we allocate this through all the Tauros in the LCA calculated, this would be 0.4% of climate impact, what we have to calculate for this repair scenario. But of course, when we exchange component, this means we do not have to exchange the whole device, and this I will tell you on the next few slides. So here you can see the repair procedures we modeled for the Tauro lifecycle assessment. For example, the exchange of the power unit, exchange of the data communication unit, the so-called pilot, the exchange of the control port, and the external fan. And here you can see one example. When a Tauro would be, for example, we have a defect after 10 years, so an error after 10 years, a failure, then the repair generates maximum 147 kilograms of CO2 emissions. When we repair, for example, the power stack, that's 147 kilograms. When we would replace the entire Tauro and after this 10 years, this would result in more than 1 ton of CO2 emissions by just replacing the entire unit. So the message is really, please repair your products, repair the Tauro, because repair provides a high environmental benefit. So that's 10 times the number, nearly 20 times the number, what you can save with a repair scenario of the Tauro. The Tauro is best suitable designed for repair scenarios. And the last one is the waste recycling. I told you in the beginning, we have a environmental voucher, a climate voucher here with minus 2.8%. Why is this a negative value? The negative value comes from the credits from primary production or replaced fossil energy sources. We said in our scenario, this is this one, the metals are recycled, so we can use the aluminium again in a primary production, and so we have a negative value here. But there is also Other scenarios, for example, when we would just landfill the inverter, then we would have a positive value here, a positive value in the climate balance, meaning a negative impact on the environment. So effort versus benefit. I always talked about the environmental efforts, the impact, what the inverter is producing. But in this chart, you can see the benefit of the inverter is generating. So in this LCA, we calculated a lot of different scenarios or categories, let's call it categories, like fossil resources, metallic resources, and so on. But the most important is definitely the impact on the climate. And you can see here, the impact the inverter is generating is this red bar, and the benefit the inverter is producing over 20 years of lifetime is this bar. So the benefit is up to 52 times higher than the impact the inverter is generating. This is huge. And we can express this in a CO2 payback time. This is the time the inverter takes to be carbon neutral, to work off the carbon backpack of the inverter from production and so on. So let's call it a break-even point, a climate break-even point, so to say. And for our example in Germany, it would take the Tauro 1.1 year to be carbon neutral. After 1.1 year, the inverter is net zero, and then it produces everyday green electricity for the energy transition. And over all scenarios, the best case would be Australia with a payback time from 0.4 years. So in just 5 months, the inverter is carbon neutral. Worst case is Brazil with 2 years, which is also not a bad value, I would say. We also calculated the energy payback time. So the overall energy, the payback time is here 0.3 to 0.8 years. And the CO2 payback time of the whole PV system, including the PV modules and so on, is in Germany 1.7 years, and overall scenario 0.6 to 3 years. Just a quick summary of the results. As I said, the environmental benefit exceeds the impact by a factor from 10 to 52 times, so 52 times more benefit generated from the Tauro for the environment than it impacts it. Up to 223,000 kilograms of CO2 equivalent are saved with a Tauro. This is up to 200 flights from Vienna to New York, which a Tauro would compensate here. 200 flights from Vienna to New York. This is a huge number. And as I said, the payback time in terms of climate impact is in the range of 0.4 to 2 years. The key statements, just to sum it up again, the repairability provides a high benefit in terms of environment compared to the whole unit replacement of the Tauro, for example. A big leverage is again the CO2 footprint of the PV modules when it comes to electrical losses, and of course the efficiency of the inverter. And third one is of course the aluminum recyclate share, the high share we have from recycled materials here also has a positive impact on the CO2 footprint. Now you maybe will ask the question in the end, how can I use this life cycle assessment as an installer, as an EPC, as a planner, as an end customer maybe? Of course you can use the life cycle assessment. I just sum it up again. I already told you in the beginning, the first one is economic safety for your business. I told you the environmental impacts of course of products are coming or be required in tenders more often. As I said with the German, with the France example, the public tenders are already requiring this carbon footprint calculation. So with the LCA, you save your economy. Then of course, upcoming pricing for CO2. As I said, the prices are rising, and so the inverters with a low carbon footprint will be preferred in future because they are cheaper. Of course, you can use the LCA for image reason, sustainability as a figurehead for your installation company. I am an installer just installing green inverters with a life cycle assessment, with a low carbon footprint. This is also good for your image. And of course, economic efficiency versus environmental awareness. I think it's clear for everybody that PV system pays off now in terms of the monetary look, the monetary view, so in terms of money. So the ecological factor is becoming more and more important in a buying decision, for especially in future generations. You want to have a secure future for your children, for your grandchildren, and therefore you really should also consider the carbon footprint of products and not only the price. So be part of the energy transition with a Fronius inverter with the life cycle assessment. And of course, we have further information if you are interested in a life cycle assessment. We also have a white paper where we explain this LCA in far more detail. So just I linked it here. You get the slides afterwards, then you can download the paper. It's also on our website. And of course, it is certified by Fraunhofer IZM. So this is the Fraunhofer Institute in Germany. They did a review of the whole life cycle assessment that our LCA is compliant with the ISO guidelines, ISO 1444 and ISO 1440. So also the certifications on our website here. Yeah, that was basically all from my end here. I now take a short look at the questions. Maybe we have some questions in the window. I think my colleague answered all. So I will just stay online for a few minutes if you have some more questions. And then I will close the webinar. I wish you a great day. Thanks for joining and see you soon. Bye, guys.